In this part of section 5.4, we're going to look at factoring polynomials that have a leading coefficient other than 1 on the highest term in that polynomial. We have two methods. One is a guess and check. The other method I'm going to lay out for us, and then we'll come back to it. So while we're at the note sheet, let's write down those steps, and these may both be a mystery to you, but hopefully I'll straighten that out for you. When we have a trinomial of the form ax squared plus bx plus c, and we're going to use the grouping method to factor, the first step is to multiply the a coefficient from your highest power and your constant term, so a times c. The second step is to find a combination of factors that multiply to give you ac whose sum equals b, the coefficient of your linear term. Then you are going to rewrite the trinomial middle term bx using those factors, and then we are going to factor by grouping. And I'm sure this is absolutely Greek and you're ready to hit click, shut this off, but hang on, I'll show you these two methods, and I think most of you probably will like this grouping by factoring method. But let's start. So here we have a trinomial that they're asking us to factor. We no longer can use the what multiplies to give us this term and add up to give this, because now all of a sudden we have this 2 out here from our leading coefficient. So what we can do is, one of our procedures is to do the guess and check. And what that entails is, think about what would we have multiplied to give us 2x squared? Well, since 2 is prime, there's really only one option. A 2x and an x would be the only way that we could generate that first term, multiplying the first terms in the polynomial. And likewise, since this is 3, and a result of multiplying our last terms in our binomials together, the factors are 3 and 1. Both of them are the same because this is positive, and we look here, they were both positive. So to get that last term, it was a 1 and 3. It's not an automatic just writing those 2x and x and a plus 1 and a plus 3 automatically given. We need to check and see if this arrangement generates the middle term. I'm pretty guaranteed that the first term will give us a 2x squared and the last term will give us a positive 3, so we're good there. And that is kind of silly because those terms were generated from the factors of the first and last. What we need to look at is this arrangement going to give us the middle term that we want? So we need to check our outside. 2x times 3 is 6x. Multiply our inside, which is x. Add them together, and we've got it. So first time out of the chute, we have the correct answer. Had this not worked, we could have switched around the order. And just to show you, I'm going to leave my 2x and x alone, but putting the 3 first and the 1 first, as you notice, it doesn't change the first and last in our trinomial, but our outside-inside is going to be different. 2x times 1 is 2x. 3 times x is 3x, and this would have given us a 5x middle term. Not what we were looking for, and as I said, we were lucky and got the correct arrangement. Had neither one of these arrangements generated that middle term, and we had no other options, since these were prime, we would have said that this was not factorable and a prime polynomial. It goes without saying that you always need to inspect to see if there is a greatest common factor, because it's going to make it much easier in the long run if you factor out a greatest common factor. So a quick inspection, 6 and 19 don't have anything in common. This term doesn't have an x. I can do the guess and check, but now all of a sudden, because 6 and 20 are both composite numbers, we have quite a few choices. 6x and x, 2x and 3x. Here, because it's a negative, 20 has all kinds of factors. 1 and 20, 2 and 10, 4 and 5. There's a whole combination that we would have to make sure we tried every possible combination. So here's where I'm going to jump to the grouping method to factor this, and just to help us with the coefficients, when we have a general form of a quadratic formula, I'm comparing that to this example. A is equal to 6. My signs agree. That means B, the coefficient of our linear term, is 19. And our C, the signs don't agree, but I can turn this into plus a negative. So C is equal to negative 20. On those steps that we wrote down initially, I asked you to find A times C. So we're going to take 6 times negative 20, which gives us a negative 120. That's the product of A and C. Then, in the second step, we're looking for a combination of factor pairs that add up to equal our B. And B is equal to a 19. So we're looking at a sum of our factors of negative 20. Or negative 120. So let's start. I like starting just with the smallest number. Negative 1 times 120 gives us negative 120. When I add them, I get a 119. It's not the number we're looking for. So off the plate. Negative 2 times 60 gives us negative 120. When added, gives us 58. We're looking for 19. We need to keep on going. Negative 3 times 40 multiplies to give us negative 120 and adds to give us 37. Getting closer, not there. Negative 4 times 30 multiplies to give us negative 120. But when adds, gives us 26. Not the case. 5 goes into 120, so if I keep with my negatives, negative 5 times 24 when we do our division, and when we add, we end up with our 19. We have the pair that are the factors of the negative 120. When added, give us the 19. So the next step is, step 3, rewrite the trinomial middle term in terms of these factors. So here's the original trinomial. It is 6x squared plus 19x minus 20. I'm going to replace my 19x with these two factors that I just found. And temporarily it's going to look worse than it is. So I'm going to put a plus negative 5x plus 24x, and I'm getting the negative 5 and the 20 from the pair that multiplied to equal our negative 120 and added up to be 19. These two, when you add negative 5x and 24x, they equal 19. So I've kind of blown this up, but it's still equivalent. And I still need my minus 20. So these two terms, when simplified, give us 19x. I've just gone from a 3-term polynomial to a 4-term. Looks maybe counterproductive, but now I'm going to use the factor by grouping, and that was our 4th step. First two terms, if I take those, what's common? The only common factor is x. Factoring out an x leaves us 6x. Factoring out an x leaves a minus 5. Grouping the next two terms. What's common between those two? Well, it's a number. And the greatest common factor is 4. 24x divided by 4 leaves us with a 6x. 20 divided by 4, and we have a minus there, will leave us with a 5. And if you look, both sides have that common binomial. So we will factor out the common binomial factor, takes it out of the left, leaving an x, taking it out of the right when we factor or divide leaves the 4, and this is the two binomials, or these are the two binomials when multiplied that gave us that polynomial that we started out with. We could have gotten there by guess and check, but this is kind of a cookbook method that's going to get us to our answer without fail. Let's look at another one. On this one, if I use the same method and I compare it to ax squared plus bx plus c, and I pull off those coefficients, the a, the coefficient of my leading term, is a 6. B will be a 5. C, my signs don't agree, so C is equal to a negative 6. My first step is to find what A times C is. So I'm going to take the 6 and multiply it by the negative 6 to give me a product of negative 36. I'm looking for two numbers that multiply to give me negative 36 and then add up to equal B, which is equal to 5. So we start our test. One of these factors has to be negative, one has to be positive, and I'm just starting with the integers and working our way up. Negative 1 times 36 is 36 and adds up to be 35. I'm looking for a 5. Negative 2 times 18 gives us negative 36, adds up to be 16. Nope. Negative 3 times 12 gives us a negative 36 and adds up to be 9. Closer, but not quite. 4 goes into 36 9 times. There's my negative 36 when I multiply, and when I add, there's the 5 that we're looking for. So this is our factor pair then that we will use in our next step, step 3, rewrite your trinomial middle term. So we have 6z squared plus 5z minus 6, and instead of 5z, I will write a minus 4z plus 9z, using those two factors that add up to be 5, and then I still have to have my minus 6. And if we simplify, whoops, let me slide this over, negative 4z plus 9z add up to be the 5z. So it's still equivalent, but it's now allowing me to factor by grouping. Greatest common factor, we have a 2 and a z in the first two terms. That will leave a 3z when we factor it out, and a minus 2. What's common between the second pair? There is a 3 common. Divide this term by 3, leaves a 3z. Divide this by 3, leaves a minus 2. Look at, we have the same pair or binomial in each of these terms. So factoring out that binomial from the left leaves a 2z. Factoring or dividing it out on the right leaves a plus 3. So your choice on which method you want. Leave that up to you. In this next problem, again, it's always a good idea to look for a greatest common factor. And if we look, there is a common 3. Dividing by 3 or factoring out a 3, we're left with a 2x squared. Dividing by 3 leaves a 9x. Dividing by 3 leaves a 10. And it's always a good idea to multiply and make sure that this does equal what it originally was. You have a choice then of using the grouping method that we just went through with the A, C, and the B, or let me show you the guess and check again on this problem. We have to have the 3, but I'm going to work with here. Where did the 2x squared come from? You only have one choice, 2x and x. Where did the 10 come from? It's the last term. Both signs are the same. Both are positive. And you have just two choices here, 1 and 10. 2 and 5. That's not too many options to juggle with a guess and check method. I can't forget my 3, but again, I'm just working with the trinomial right now. So we would have the 2x and x. Choosing here, I can do the plus 1 and plus 10. And if you check the outside, I get a 20x. The inside, I get a 1x. That adds up to be a 21. We're looking for 9x. Almost went up to the original one. 9x. Not going to work. But before we discard 1 and 10, we need to switch these around. I'm going to put the 10 first and the 1 second, always leaving my first terms in each binomial the same. Switching the second term will give us all the possible combinations. Let me slide this up a little bit. Check your outside. We have a 2x. Check the inside is a 10x. That adds up to be a 12x. It's not the case. So 1 and 10 don't work. Our last hope is with the 2 and 5 combination. So I'm going to leave my 2x and x as my first terms. I will put a plus 2 and a plus 5. My outside is a 10x. My inside, when I'm using part of the FOIL, is a 2x. That adds up to be 12x. That's not the case. The only other option is putting the 5 first and the 2 second. And if you notice, I left my first terms in the binomials the same. It's only those second terms that are getting replaced and switched for all the combinations. And let's see, does it work? Outside, we get a 4x. Inside, we get a 5x. Those would add up to be the 9x that we're looking for. So we found the replacement or the factored form for this trinomial here. So our final answer will be the 3 that we factored out as the greatest common factor initially, and the trinomial factors into 2x plus 5 times x plus 2. One more problem I want to look at. Looking for a greatest common factor first, and a little pause, it's got a negative out here. It's much easier if you don't have to deal with the negative. So while we're pulling off the greatest common factor, and even if it was just 1, I still would suggest factoring out the negative 1 so you're not dealing with a negative coefficient on your leading term. So to kill 2 birds with 1 stone, factoring out a negative 2 from each one of these is going to reduce our problem, our polynomial that we're factoring, and eliminate that leading coefficient being a negative. So when we factor that out, the signs change to the opposite of what they were, and we've reduced it by 2. Our mission now is to factor this. You can choose the grouping method, or again, this one isn't bad like the last one. How would we get a 2x squared? We would have a 2x times x for our first term, and last term for a negative 3, it's either a negative 1 and a positive 3, or a positive 1 and a negative 3. When it's prime numbers, the guess and check is probably the faster method, so we're looking for the arrangement that works. Starting with a 2x in x for the first term in each of our binomials, and trying the terms negative 1 and 3. That would be a positive 3. Our outside is a 6x. Our inside is a negative 1x, which gives us a 5x. We want a negative. That tells us all we need to do is change the signs. The placement of 1 and 3 is fine, but we need to change the sign. So instead of a minus 1, we have a plus 1, and instead of a plus 3, a minus 3, and let's see if that works. Outside, we would get a negative 6x. Inside would be an x. There we go. We've got our negative 5x. So Our final answer is, don't forget, the original greatest common factor of -2, and replacing the trinomial, we will write 2x plus 1 and an x minus 3.